Yes,
Can you
ma'am.
see the board? Can you see the board? Can you hear me?
Yes, ma'am.
Okay. Before we start, you need to regenerate like a eagle. Okay, you know eagle story. Once eagle become old, all the feathers will be loose and the beaks will be bent. What it will do? What it will do?
Ma'am, it will go near the mountains and
Very
it
good.
will hit
It itself.
hit
It
itself.
will fly away between the two hills and fly away between that, and it itself will. All these beaks will be broken and the nails and all it will cut by itself and feathers and all it will remove, and it will wait for that to grow newly and regenerating. It will regenerate. That is called regeneration. It will regenerate self-evaluation. Okay, so we should be like a eagle. Suppose we don't get good marks in midterm exam, don't worry. Now second term is there. You can score high marks now if you work hard also. Okay, please work hard like a eagle. Okay, and come out. So
Excuse me,
don't
ma'am.
worry.
Ma'am, we didn't finish triangles, ma'am.
We didn't finish triangles. I'll do it later. Let us complete this. Okay, we are lagging behind. So all have completed linear. They have finished the circles and they went to linear equation. Teachers, let us also complete. Okay, don't worry. We'll do that. First, we'll complete the portions. Then come back again, and wherever we have doubts and all these things, that time we'll clear. Now, circles. Circle is a collection of points from a fixed point to fixed distance. What does this mean by fixed point? What do you call that fixed point?
Center of the circle.
Very good. Center of the circle. Fixed distance. What is this fixed distance called?
Yes.
Radius. Radii, plural. 2, 3 circles. When you compare, you should write radii. One means singular means radius. So this is the circle definition. And then what do you mean? How will you define chord? Can anybody define chord?
A chord is a line segment drawn from any 2 points on the circumference of a circle.
Very good. Chord is any 2 points. Line joining. It is a line segment. It is a line segment joining any 2 points on the circumference of the circle. So AB. In the circle, AB is a chord. AB is a chord, a line segment. When you join 2 points on the circumference, we get line segment. That line segment is called chord. And the biggest chord, which is the biggest chord in the circle? Diameter.
The diameter.
Very good. The biggest chord. When you draw many cards like this, the biggest will be the diameter. This side also you can draw. That is also called chord only. Any way you can draw, and the biggest chord will come as a diameter. So the diameter is a line that passes through the center of the circle. Okay, and it meets the two. This is the biggest chord. So diameter is the biggest chord, and why it is called biggest chord? Because it is passing through the center and through the two circumference. So all these are basic. Now tell me, what do you mean by sector? Sector and segment. Sector of the circle, segment of the circle.
Sector is the area.
The area enclosed by 2 radius is known as sector.
2 radius and arc.
Very
2
good.
radius and arc.
2 radius and an arc of a circle. So we have a center of the circle and 2. So example is pizza. So you cut cake. You cut cake like this, no? And you eat, no? This part is sector. So sector is the area enclosed by 2 radii and 1 arc. So OAB. So AOB is a sector. AOB is a sector. They used to write AOB like this. Sector. It's a space occupied by the 2 radii and an arc. Okay, minor. This is minor sector. Which is a major sector? Suppose I mark here as C. So how will you tell me? This is a minor sector. Okay.
I have to put the reverse term.
Yeah, reverse. So this reverse part. A, C, B. This part. This part is major sector. So understand, the part which is a small region enclosed by 2 radii, small region is minor sector. The part which is the major, which occupies the major space by the circumference. Okay. Again, that is also two radii and a major arc. This is called major arc. This is major arc, minor arc. ACB is a major arc. ACB is a major arc. And AB, arc AB is a minor arc. So when it is space occupied by the minor arc, we call it as minor sector. When the space occupied by the major arc, we call it as major sector. That's all. Okay, segment. Now, segment. Don't say Abhishek and Amrita, somebody else. What do you mean by segment?
The area between
Area
area
enclosed by an arc and a segment.
Very
arc
good.
and a chord.
Arc and a chord.
Arc and card. Super. Card and arc like this. Okay. So one card and an arc. This space is called segment. We won't cut like this and eat cake, no. We cut like a sector and we'll eat. This will be a bigger part. So we are not eating. So what is an example for segment? Sometime, can anybody give an example for segment which we use in our daily day life? Only dosa we will eat like this. Can anybody give example of segment? In a clock also, segment.
Ma'am, in clock sector, no, ma'am.
Clock also is sector. Only 11:30, 12:30. 12:30 will come segment. 12:30.
Ma'am, that's diameter, no, ma'am.
That is diameter. Then
It's also chord only.
if it is like this,
Card, ma'am.
Okay,
if
the
it is
longest
like
chord.
if the
Diameter is
clock
also
is
chord
like
only.
this. Yeah, chord only. Diameter is the biggest chord. So we can take that also as a segment. Semicircle also we can take it as a biggest. Semicircle is a segment. When it is exactly divided into half, we call it as semicircle. Okay, that is also segment. Correct. Very good. That is also segment. So segment also we have a
Largest
minor.
segment.
Minor segment. There also you have minor segment, major segment. There also we have minor segment, major segment. We are going to learn detail in area of the circle this chapters. Okay. So now we will learn only about tangent in circles chapter. Okay. These are all is introduction. Let us go to tangent. Before we go into tangent, first there are three situations. When a circle and a line. So one is like this. Another one is like this. Okay, another one is like this. So what do you call the first situation?
Non-intersecting line.
Non-intersecting line. Very good. So when the line and the circle, a line and the circle doesn't touch each other, it is non-intersecting lines. Very good. Second one we call it as secant. SECANT. The line which touches with 2 points. The line and the circle touching. The line and the circle touching this given circle in 2 points, like A and B. It is touching in 2 points. We call it as secant. Not D, T, sorry. SECANT. Secant. Okay. And now which we are going to learn is tangent. Tangent means it touches only with 1 point. This circle is wrong.
Ma'am, you have to let Kritika in itself, ma'am.
Seema, what time she is entering and she is telling me to enter. It's supposed to end the class now. 11:34. Take advantage of Seema. These 2 points coincide in 1 point. No, that point is called tangent. So it is also given. The tangent to a circle is a special case of secant. Tangent in the circle is a special case of secant when the two endpoints of its corresponding chord coincides. When two endpoints coincide means what? Merge, come to 1 point. When 2 points come in 1 point, we call it as tangent. So how will we define tangent? Tangent to a circle is a line that intersects the circle at one and only point. All these are there in a textbook. So first you write circles and write introduction. In the introduction, you write the definition of the circle. Okay. First you should write what? Definition of the circle. and definition of the diameter, radius. Okay. Then chord. Today's homework, please check leaders. I'll also check. Okay. I'll also check. You also check. 5. Google Classroom. Okay. Start from today. New term. Circles Classroom. You put Google Classroom. We'll check. Diameter, radius, chord, segment, sector, and all you write. Then go to these 3 situations. Which are the 3 situations? Non-intersecting lines, secant, tangent. Draw neatly. Don't draw like Gina ma'am. You draw neatly and write neatly. Okay. Introduction. What is tangent? Because introductions is important for concept. Now, then you write the definition of tangent. What is the definition of tangent? Tangent to a circle is a line that intersects the circle at only one point. Tangent is the line that intersects the circle at only one point. That's all. Now we will learn one theorem and we will leave. Okay. What is a theorem? The tangent theorem. Very important theorem. Again, this theorem 3 times you should write. Very, very important theorem. This theorem is also called tangent radius theorem, but it is not named like that in your textbook. This theorem, we used to call them like that, but the name, it is not named in your textbook. So rarely you use. Second time when you are using, you can always use that name. Otherwise, you should write the full theorem. What is the theorem? One of you can read page number 209. 208. Tangent radius theorem.
Ma'am, I will read it, ma'am.
Yes, please read.
The tangent at any point of the circle is perpendicular to the
Wait.
radius.
Tangent at
Any point of the circle, is perpendicular to the radius through the point of contact. Point of contact. Yes, ma'am.
So given is a circle. You should always start like this in this question. Given is a circle. Circle, you use this. We are using this symbol. Given is a circle. Given is a circle where O is the radius of. Always you should write where O is the center of the circle. O is the center of the circle and radius. Suppose you are using one radius. In your textbook, we have a radius like this, okay? XY. And radius is OP. Okay, you should write that. So, given is a circle where O is the center of the circle and OP is radius. OP is the radius of the circle. OP is the radius of the circle. Always write the given to prove, always. Okay. So whenever you start with any problems in geometry, especially given to prove, all this also will carry marks. So they understand how nicely you are understanding the theorem. Okay. Given. What you have to prove, you see, the tangent at any point of a circle is perpendicular to the radius. To the point of contact. What do you mean by point of contact? The tangent touches the circle. I told one and only point. That one and only point is called point of contact. The tangent touches the circle at one point. That one and only point is called point of contact. So at the point of contact and the radius is perpendicular, you need to prove. Don't mark here. If you mark, you will go wrong. So don't mark. You write here. OP is perpendicular to XY. You need to prove this. OP is perpendicular to XY. So theorem should be proved like this, given to prove that. Construction. So construction is, you need to mark a point here as Q. Mark point Q on XY and join OQ. You need to join this OQ in dotted lines. You need to join OQ in dotted lines. Okay, that's all. Now proof is started. So how will we prove it? We prove in such a way that first we'll start OQ is bigger than OP. What is the reason I can give? OQ is greater than OP. Why?
Ma'am, since OP is the radius, OQ is longer than the radius, ma'am.
Yeah, OP is radius. See here, P will come here. Suppose you mark here one point, R. So definitely OQ consists of OR plus RQ. Correct? No. Because Q is outside. Q is outside the circle. Q is outside the circle. So OQ consists of OR plus RQ. Right? So OR is nothing but OP. Why OR is nothing but OP?
Radius, ma'am.
Radius.
Radii are equal, ma'am.
You draw anywhere radius, children, you will get same measurement. And only it is called circle. Otherwise, it's not called circle. Radius means constant distance. Never change. So OP should be equal to OR because all are radius. You need to write this reason correctly. Okay. So why OQ is bigger than OP? You need to write this reason. Q is outside and OQ is nothing but OR plus RQ. OR and OP are radius of the circle. That is why. Okay. Now you have learnt in 9th standard this theorem. You remember this theorem, you check. Of all the straight lines, you draw many lines here. You remember this? Of all the lines you have drawn, perpendicular is the shortest. You remember that? Suppose one external point is there and one that according to that theorem only. Here OP is shortest. Correct? No. OP is shortest. OP will be shortest. So shortest is the see here. You draw many lines like this. All the lines OP will come shortest according to this theorem. And shortest is the perpendicular. So what is this theorem? You need to write the 9th standard theorem. What you learnt in 9th standard. Of all the lines drawn from external point to the line, drawn from external point to the line, of all the lines, many lines we can draw, but only the shortest, the perpendicular is the shortest. Of all the lines drawn from external point to the line, the perpendicular is the shortest. The perpendicular is the shortest. So here the shortest is OP. Therefore, OP is perpendicular to XY. That's all. Is proved. OP is perpendicular to XY is proved. Very simple, no? But what all is necessary? You see, this theorem is very much important. This theorem is very much important. This diagram and this theorem you write. And then why OQ is bigger than OP you write? Because OQ is outside the circle. OQ is equal to OR plus RQ. And OP and OR are radius of the circle. All this you should write. Every line is important. One line also you should not miss to get 3 marks. This is a 3-mark question. So remember the tangent radius theorem. So first you write 1 time in your classwork and 3 times as a homework you do this theorem. And then you do exercise 10.1. One of you read 10.1. We'll just discuss 10.1. Exercise 10.1.
10.1. Page number 209.
209.
First question. How many tangents can a circle have?
How many tangents you can draw in a circle? Many tangents, every side.
Infinite.
Many. See, that is why in physics you have learnt last time circular. Did you learn in physics 9th standard? Circular motion is accelerated. Why it is accelerated? Why it is accelerated? Why it is accelerated? Do you? Are you? Why ma'am? You are asking physics questions in maths. Why ma'am? We forgot everything. 10th portion itself we forgot. You are asking 9th standard portion.
Ma'am, because the direction keeps changing, ma'am.
Very good, super. Abhishek learned physics correctly. So
Anirudh,
super Anirudh. Clap for Anirudh. Anirudh only we should clap. So thank you. Okay, that means 9th standard you have studied correctly. It is moving with the direction. Direction also changes. Everything is changing. See, vector quantity, direction also changes and magnitude also changes. So only suppose you take one stick, what do you call, one stone, tie with your thread and you rotate. So that thread, if you release it suddenly, it will go like this, like a tangent. Okay, so there are many tangent, infinite tangent. What do you mean? This stone is infinitely changing the direction in every situation. Suppose if it is square like this, means only 4 times it will change. If it is hexagon, means 6 times. Heptagon, octagon, means 8 times. But many times it is changing in the circle. That is why accelerated. So according to that only, here it is infinite will come as answer in the first question. Okay, so how many tangents you can draw? How many tangents you can draw? Infinite tangents. Many tangents you can draw in the circle. Many. Uncountable. Infinite. Okay? Infinite means what? Not uncountable. Infinite means a large number. Next question. Fill in the blank. Who's reading? Again. Okay, a tangent to a circle intersect to its a dash point. Tangent will meet on only one and only point.
1 point.
Like that, fill in the blanks and all is given, ma. So you can try that on your own. A line intersecting to a line 2 points is called secant. A circle can have 2 parallel tangent or most. So you can, in one circle, parallel means 2, like this you can draw 2 parallel. This side one pair like this. Parallel we can draw. Okay, many parallel actually we can draw. Okay, the circle can have dash parallel tangents at the most. At the most, how many parallel tangents can be drawn? Common point of a tangent to a circle, and the circle is called point of contact. I told you there will be a common point here. This point is called point of contact, like that. All one word answer only. So please complete exercise 10.1. Before that, do introduction, like important points to remember. You write important
Ma'am,
points.
ma'am, once can you just give the glance of third sum, ma'am, how to do just like that?
Okay, a tangent PQ at a point P. A tangent PQ at a point P of a circle of radius 5 centimeter. This is 5. Okay, and meets a line through the center of the circle at the point Q, so that OQ is 12. Okay, the tangent PQ at a point P of a circle PQ. Okay, and meets the line through the center O at the point Q, so that OQ is 12. So OQ is 12. O here, OQ is 12. This is 12. So this is 90 degree. Pythagoras theorem. Okay. So what you will do? What is Pythagoras theorem? OQ square is equal to
OP square plus PQ square.
So what happened? 12 square plus 5 square. What is 12 square? 144.
Ma'am, 12 square is equal to 5 square plus OP square.
Correct. 12 square is equal to 5 square. 12 square is equal to
PQ square.
5 square plus PQ square, x square. So find out what is x square. 144 minus 25.
25.
120.
119.
119. So x is equal to square root of 119 is the answer. Okay. You use Pythagoras theorem, explain. Okay. Don't write like MCQ, you write explanation you do. Okay, children? All the best. Get ready for the next class. Tomorrow we don't have class. Thursday we'll continue with mathematics and then we will do physics. Physics experiment I'll be sending. So I'll go to school and try to send the experiment. Okay.